Hi, and welcome to the Bare Basics, where today we're going to be looking at plotting points and equations on a Cartesian plane. It's a fairly basic skill, but one that will make life a lot easier for you if you know how to do it properly. Alright, so let's start by looking at a Cartesian plane. What you have here is basically two number lines that intersect at right angles. The x-axis goes horizontally across your screen with positive numbers to the right-hand side and negative numbers to the left. The y-axis runs vertically. Once again, it's a number line, so the positive numbers are increasing as you go up your screen and they are decreasing as you go down the screen. All right, now in order to be able to plot points on the Cartesian plane, we use something called an ordered pair or a coordinate. An ordered pair gives the directions that we need to plot the point on the Cartesian plane. So, for example, let's take the point P, which has the coordinates of 3, 4. Now, the first number in the pair, gives us the distance and the direction to go along the x-axis. So think about the alphabet. X comes before Y in the alphabet. Therefore, we plot the x-axis before we plot the y-axis. So let me find my mouse here. So we start at 0 and we follow along the x-axis until we get to the value of our x-coordinate, which in this case is 3. We then go up or down, as the case may be, as the second number in the pair gives the distance and the direction to go parallel to the y-axis. So we follow the line that starts at our 3 and we go up. Now I've just lost my mouse again, so let's find it. There we go. So we're following up our line here until we get to 4 because it was positive 4, so we go up to 4 and there is our point at P34. Okay, so let's try plotting a couple more points just so you can see what happens. So it works the other way as well. So if we've got the point first, what we do is we start at the origin, that's point 0, 0. And as you can see, we have to move to the left to get to our point along our x-axis. So we would actually go out until -4. So our x-coordinate is going to be -4. And from there we go up, which means our y-coordinate is going to be positive to +2. So our first point, or point A, is -4, 2. Working from the coordinate again to the point. So this time, once again, we start at the origin and we have to go along the x-axis to -6. And then our y is a negative. So that means we're going to go down and we're going to go down to -4. So our point at -6, -4, there it is. And our last one, once again, we're going to be given a point. Now this time our x value is positive, so we're going to go along the positive side of the x-axis until we get to 6. And then we've got to go down. So our y value is going to be negative, so it will be 6, -2. Hopefully you can now both read a point and work out what it is, and you can also plot a point if you've been given it. Now, once you know how to plot the points, we can move forward to being able to actually plot an equation. Now, any equation can be plotted onto the Cartesian plane. And the first step is to work out the ordered pairs that we've just seen that form the path of the equation. To do this, we create a table of values. Now, say for example, our function or our equation was y equals 2x minus 1. So we draw up a table and we put in some x values. Now we can choose any x values that we want, and what I generally recommend is 3 to 5. Particularly in this case, so if we look at our function here, y equals 2x minus 1, that is in the general form of a straight line, y equals mx plus c. So if we choose at least 3 points there, we know that if they're not forming a straight line, then one of those points is incorrect, and we need to actually recheck what we're doing and redo our work. So what I've done is I've chosen a number of x values. I've chosen 2 negative, I've chosen 0, and I've chosen 2 positive. So that should give me a fairly good spread across my x-axis. Now these are independent variables, our x-axis. That means we can choose any values that we want. The y value will change depending on the x value. So let's take the x value, -2, and let's find that mouse again. There it is. So we're doing x equals -2. So to find our y value, we substitute in. So 2 times -2 instead of x, 2 times -2 is -4, minus 1 gives us -5. When x is -1, 2 times -1 gives us -2, minus 1 gives us -3. When x is 0, 2 times 0 gives us 0, minus 1 is -1, with 1. 2 times 1 is 2, minus 1 is 1, and finally 2 times 2 minus 1 gives us 3. Now we have a table of values, and what this actually gives us is a set of ordered pairs. So our first one is -2, -5, and you can see it plotted there. We have -1, -3, 0, -1, 1, 1, and 2, 3. And you can see there that I have confirmed what I originally said, that we were in the form of a straight line, y equals mx plus c, and there is our straight line. So we've now graphed that equation. It also works with nonlinear equations, such as the quadratic function that I have here, y equals x squared plus 2x plus 1. So we follow the same procedure. We create a table of values. So here's our equation. And once again, I've chosen the 5 points to go across my x-axis, and then I've simply substituted them into the equation to find out what my y value is. So with the first one here, let's find that mouse. So we've got, when x is -2, we'll end up with 4 plus -4, which of course will be 0, plus 1 gives us 1. When x is -1, this becomes 1 plus -2, which is -1, plus 1, which is 0, and so on. Once again, that then creates sets of coordinates that I can graph, and we have a quadratic equation there. For a final example, we can use a reciprocal function. So this is just showing that we can do it with any type of function or equation. Okay, so our table of values. So say our graph is y equals 2 on x. So it's a reciprocal because our x is on the in the denominator there. So once again, here we've got our values. Now, you'll notice I've got u/d when x is 0, and that's because we can't divide by 0. So our y value is actually undefined when x is 0, which means that we've got an asymptote. That means that that's a line that our graph gets really close to, but never actually touches. In this case, we've also got an asymptote because it's undefined when x is 0. It means it's undefined when y equals 0 as well. So it means that our graph will not touch either the x-axis or the y-axis. So we've got some points there. So once again, we can note those down. Undefined means it's not going to touch there, and it's going to start again. And if we pop in our lines, it's going to be what we know to be a hyperbola. So this video has just given you a quick overview on graphing points and also how to use those individual points to graph an equation. So if you have any questions, if you're in my class, just ask me, or you can email me, and there's my EQ address. So in today's lesson, we've looked at graphing points and equations on the Cartesian plane, and I hope this episode of the Bare Basics has made maths a little bit more bearable for you.